This section 5.3 still graphs of rational functions, and we are going to do this graph here. This is number 5. We've got, or letter 5, and we've got x over x minus 1 all squared. So always first step, whole. So we're going to say whole. Is there one? No. Whole. Okay, or none. I've been saying none. I think I'll go back to that. So none. Whole, none. And vertical asymptote. So we're going to look at the denominator. So the denominator is x minus 1 squared, and we just need to state it so x equals 1, just one time. Okay, and then horizontal asymptote. Horizontal asymptote, we're looking here. This is a degree 1 on the top. Remember, this is a degree 2 on the bottom because it's x squared. So since the denominator is bigger, we're going to say that y equals 0. Okay, and then oblique asymptote, none, because there's already a horizontal asymptote. So we're good there. Now we're going to do the x-intercept, y-intercept. So let's do x-intercept when y equals 0. So 0 equals x over x minus 1 all squared. This goes up here, right? So it's crossed off, and then we're going to get 0 equals x. So I get one x-intercept there. And now let's see if I get y-intercept. Well, y-intercept, once you know the x-intercept is 0, your y-intercept is also going to be 0. So just so you know, y equals, it'll be 0 over 0 minus 1 squared. That's gone, doesn't matter because it'll be y equals 0. So those always match, right? When it's 0 here, it's got to be 0 there. What else do we have now? We are going to get the domain. So domain, I always say the domain, I'm just going to put some lines here so you can see my answers. I've got here, for my domain, the domain I always look at restrictions. Restrictions always comes from the whole and the vertical asymptotes. So for my domain, then I know that x is going to be from, and there's no whole, but there's a vertical asymptote, so this will be from negative infinity to 1, or from 1 to infinity. Okay, and that's my domain. Positive and negative intervals, so we're going to do the positive, negative, positive, and negative. We'll come back to that in a minute after I graph. If you're doing the graph anyway, sometimes it's easier just to draw that or to get that information from the graph. So I'm going to draw what I have so far. Okay, just so I can see what I have right here. And what I have so far is a horizontal asymptote at 0, y equals 0. Draw and label, draw and label. This is at y equals 0. A vertical asymptote at 1. This will be x equals 1. And there's an intercept here, so this will be at 0. Okay, x equals 0, y equals 0. Now, don't have anything else. So this actually gives us a very little information. We don't know if the asymptote goes from under back up, or it could be heading down. We don't know. There's a lot of information that's missing. Same as on this side. We don't know if the whole function goes here or over here. There's not enough information. So this is one of the scenarios where the check method that we talked about is super useful. So we're going to do the check. So for my vertical asymptote, my check, there's two checks, is going to be, it's at 1, so minus, I always do minus 0.01 and add 0.01. That's kind of my standard there. So if I do 1 minus 0.01, it would be at x equals 0.99. And I'm also going to do a second check at x equals 1.01. So I'm subtracting 0.01, adding 0.01, right? So it's always minus 0.01 and add 0.01. And again, that's in my brain for both my checks. Then you're going to find your y value. So my y value for this, when I plug it in to here, is 0.99 over, and then make sure you can do your brackets and your calculator work, and I got 0.9900 exactly. Here, when I put this one in, I got exactly 10,100. So then that means that this is a very large number, and that's a very large positive number as well. So the information I get from there is that on both the left and the right, so this is left of 1 and right of 1, both of them are heading up. So that's the information I have so far. I don't know anything else, but I know that that's heading up on both sides. So now I've got a better idea of what's happening. From this, so that's my check, then my approach. So if I ask you the word and I say approach, okay, you don't have to put this in your answer, but my approach, okay, so that word doesn't have to be in your answer. You can go right to the next step, and then you're going to say the limit as x approaches, so that's an arrow, x approaches 1, and you're going to say from the left, so a little negative, of the function. You can still use f of x, that's fine, even though it's y that's given in the equation, and you're going to say it's infinity because it's heading up. So the limit, again, as x approaches 1, this will be from the right, so a little plus there. And yes, we usually let you, if you just put f of x, that's fine. It should be y, but most people just put f of x there, and we kind of do infinity. So both of them are heading up. Then my second check is going to be my horizontal asymptote. So my horizontal asymptote, my check goes like this. So check, and for the horizontal and oblique, always, 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 it's going to be at x equals negative 100. And again, you can do bigger numbers, but usually 100 is enough. Right? Looking at your scale, if I'm going by ones, 100 should be enough. If I was going by tens, maybe you want to do 1,000. Right, but this is at 1, so the asymptote's at 1, so it should be fine. When I put this in, I got a y value approximately, and I'm not showing the calculator work, but I put this into my calculator, and I got approximately negative 0. Now, you can decide. I'm not going to state exactly how many decimals. You have to use a bit of logic here. This ends up being 0098. I want to keep a few more decimal places, so I'm going to keep 4 this time. So there's no set standard. I usually say use a little bit of logic there because you don't want to round this all the way up to 0.01. You're comparing it to 0, so you might as well keep an extra couple decimal places. So I did 4, so I kind of keep the same on both. What you're going to do from this is you also want to write the word compare. So both horizontal and oblique, you want to write the word compare, C-O-M, compare, and you're comparing it to y equals 0. So you're always telling me where you're standing. For both horizontal and oblique, I'm standing on this line, so that's my comparison line. So I write that down here. So I say compare, and then my compare. And then, on both of them, compare it to y equals 0, where you're standing on that dashed line right here. So if I'm standing on that line, then it is going to be, this is a little bit below. So you're going to say, therefore, below my line. So it's coming up from below me. I'm going to be standing on the line going, yikes, there's something below me. And this one here, it's 0.0102, so therefore it's above. So you're writing all of this. So all of this must be written. So if we ask for a check, it's all of these steps. So check what you're checking, your y value, what you compared it to, and below. The whole thing. If we're asking just the approach, your conclusion from there is the approach. So you would say, I'll write this part here, so you're going to say the limit as x approaches, and this will be negative infinity, it's the negative side of the function, equals, and then you're going to say 0 from below. And this one, the limit as x approaches infinity of the function is 0 from above. So if we ask only approach, it's only this bottom line here. So that's the approach, okay? So then from here, we know on the left side, it's heading from below. So these guys here, it's below, and then this one here is from above. So that kind of makes sense because we don't have another x-intercept, so it does this way. And then this one here, because it's heading up, it means it must come through 0 and then turn around and kind of do this. I'm going to erase this part here. So it's going to be a bit smoother. So what's missing, the part that we don't get without the calculus part, is the concavity and kind of where it twists a little bit here. There's a little bit of a point of inflection right there, but don't make it too twisty. We don't want anything else happening on the graph other than kind of nice smooth curves. Don't add extra cubic things. All right? That's what we should get. That's the end of that, and then that was our graph.